Hello, everyone. Welcome to our Deep Dive podcast, where today we'll be reviewing the paper PromptEnhancer, a simple approach to enhance text-to-image models via chain-of-thought prompt rewriting from Tencent Hunyuan. Are you ready to explore the world of prompt engineering and text-to-image models?
Absolutely. This paper is quite exciting, especially since it addresses a persistent challenge in text-to-image T2I diffusion models, the gap between user intent and the generated image. Shall we start by discussing the motivation behind PromptEnhancer?
Yes, let's do that. The authors point out that while T2I models like Stable Diffusion, Imagen, and Hunyuan Daiti have made huge strides in generating high-fidelity images, they still struggle with complex prompts. For example, they often misinterpret attribute bindings, negations, or compositional relationships. This leads to images that don't match what the user actually wanted.
That's right. And the root of the problem is that user prompts are often ambiguous or too concise. The models can't always infer the user's true intent, especially when the prompt is underspecified. This is where prompt rewriting comes in, correct?
Exactly. Previous research has tried to address this by automatically enriching user prompts, but most existing methods are either model-specific or rely on generic reward signals like clip scores. These approaches lack universality and fine-grained feedback, making them hard to adapt to new models and computationally expensive.
So the key innovation in PromptEnhancer is that it's a universal, model-agnostic prompt rewriting framework. It doesn't require any changes to the T2I model's weights. Instead, it decouples the prompt rewriter from the image generator. Can you explain how this decoupling works?
Sure. The core idea is to have a separate rewriter, called the CoT rewriter, which uses a chain-of-thought methodology. This rewriter systematically breaks down the user's prompt, analyzes it for ambiguities, and then reconstructs it into a detailed, explicit prompt. The enriched prompt is then fed into any T2I model, which can generate a more accurate image.
That's a clever approach. But how does the CoT rewriter know what details to add or clarify? How is it trained to do this effectively?
Great question. The training process is guided by a reward model called the AlignEvaluator. This model is trained to provide explicit, fine-grained feedback based on a taxonomy of 24 key points, organized into 6 categories. These categories cover everything from linguistic understanding and visual attributes to compositional relationships and world knowledge.
So instead of a single, holistic score, the AlignEvaluator gives detailed feedback on multiple aspects of the image-text alignment. This allows the CoT rewriter to learn how to generate prompts that maximize alignment with the user's intent. Is that correct?
Yes, that's exactly it. The training process for the CoT rewriter has 2 main stages. First, it's initialized via supervised fine-tuning SFT on a large dataset of user prompt-reprompt pairs. Then, it's further refined using reinforcement learning, where the AlignEvaluator provides the reward signal.
Let's talk more about the data pipeline. How do they construct the dataset for SFT and reinforcement learning?
The SFT dataset is built through a multi-stage process. First, they simulate user prompts from a large image pool using an image captioning model. Then, a powerful language model, like Gemini 2.5 Pro, generates detailed chain-of-thought reasoning and multiple reprompt candidates for each prompt. Human annotators then select the best reprompt, and automated filtering ensures quality.
That sounds like a robust pipeline. The final SFT dataset contains 485,119 high-quality instances, each with a user prompt, a chain-of-thought reasoning sequence, and a reprompt. What about the reinforcement learning stage?
For reinforcement learning, they use a separate set of about 50,000 prompts, constructed in a similar way but from a disjoint image set. This ensures that the model learns to generalize its rewriting capabilities and doesn't overfit to the SFT data.
Now let's discuss the methodology in more detail. The CoT rewriter is based on a large vision language model. It takes the initial user prompt and reformulates it into an enriched prompt. The AlignEvaluator then assesses the generated image and prompt pair, providing a scalar reward signal.
Correct. The training objective is to optimize the code rewriter so that it generates prompts that maximize the reward from the AlignEvaluator. The process starts with SFT to teach the model the chain of thought format, and then uses Group Relative Policy Optimization, GRPO, for policy alignment.
GRPO is a reinforcement learning algorithm, right? It allows the model to generate multiple candidate prompts for each user input, and the AlignEvaluator ranks them based on how well the generated image matches the user's intent.
Yes, that's right. The best performing prompts are used to update the rewriter's policy, encouraging it to generate prompts that lead to higher rewards in the future. This iterative process gradually improves the model's ability to rewrite prompts effectively.
Let's talk about the AlignEvaluator in more detail. You mentioned it's based on 24 key points. Can you give some examples of these key points and how they're organized?
Of course. The key points are grouped into 6 supercategories: linguistic comprehension, visual attributes, action and interaction, relations and structure, world knowledge and reasoning, and scene text and typography. For example, under linguistic comprehension, there are points like negation and pronoun resolution. Under visual attributes, you have object counting, size, material, and expression.
That's very comprehensive. It allows the AlignEvaluator to provide nuanced feedback on a wide range of challenges, from understanding negations to rendering specific materials or capturing complex interactions.
Exactly. This fine-grained feedback is what sets PromptEnhancer apart from previous methods that rely on generic reward signals. It enables the code rewriter to learn the nuances of prompt following and avoid common T2I failure modes.
Now let's move on to the experiments. The authors conducted extensive experiments using the Hunyuan Image 2.1 model as the base T2I model. Importantly, the model's weights remain frozen throughout the training process, demonstrating the plug-and-play capability of PromptEnhancer.
Yes, and all methods are evaluated on a newly curated benchmark designed to test a wide range of fine-grained alignment capabilities. The results are impressive. On average, PromptEnhancer boosts accuracy across all 24 evaluation dimensions by plunge 5.1%.
That's a significant improvement. The most pronounced gains are in categories that require sophisticated reasoning, such as similarity relation (AC 17.3%), counterfactual reasoning (AC 17.2%), and counting (AC 15.0%. There are also notable improvements in pronoun resolution, expression, and cross-entity binding.
Indeed. In total, 15 categories show an accuracy improvement of more than 5%. This demonstrates the comprehensive impact of the prompt rewriting strategy. However, there are a few areas where the gains are neutral or slightly negative, such as text layout and interaction without contact.
That's interesting. The authors suggest that these minor regressions may be due to overspecification or ambiguity introduced by the rewriting process, but overall, the benefits far outweigh the drawbacks.
Absolutely. The qualitative comparisons in the paper also show that images generated from enriched prompts are much more detailed, stylistically accurate, and faithful to the user's intent compared to those generated from raw prompts.
Let's discuss some of the qualitative examples. For instance, when the user prompt is, "A cute penguin, wearing an astronaut suit and a red scarf, is floating and roaming in space," oil painting style with thick brush strokes, strong texture, and distinct layering of pigments, the PromptEnhancer expands this into a much more detailed description, specifying the penguin's body, the suit, the background, and the painting style.
Yes, and this level of detail helps the T2I model generate images that are not only visually richer but also more aligned with the user's original intent. The same goes for other examples, like posters, wildlife scenes, and even famous artworks like the Mona Lisa with pearl earrings.
The system prompt for reprompt generation is also quite sophisticated. It follows a hierarchical structure, starting with a general overview, then moving to a systematic and spatially organized description, hierarchical object description, and finally a stylistic identification.
That's right. The grammar is precise and descriptive, using present tense, a mix of active and passive voice, prepositional phrases, and rich adjectives. This ensures that the expanded captions are objective, detailed, and suitable for image generation models.
The chain of thought process is also crucial. It guides the rewriter to analyze the core elements, composition, attributes, actions, style, logical relationships, and even world knowledge before generating the final prompt.
Exactly. This structured reasoning process is what enables the Code-T rewriter to systematically enrich the user's prompt and address potential ambiguities or underspecifications.
Let's talk about the broader impact of this work. How does PromptEnhancer fit into the landscape of T2I research and prompt engineering?
PromptEnhancer represents a significant step forward in bridging the gap between user intent and model output. By decoupling prompt enhancement from image generation, it offers a universal, scalable solution that can be applied to any pre-trained T2I model.
That's a big deal, especially as T2I models become more widely used in creative industries, design, advertising, and even education. Users no longer need to be prompt engineering experts to get high-quality results.
Exactly. And by leveraging fine-grained evaluation and reinforcement learning, PromptEnhancer sets a new standard for prompt optimization. It transforms evaluation from a passive measurement tool into an active training signal.
The paper also situates PromptEnhancer within the context of related work, such as DALL-E, Imagen, and Stable Diffusion, as well as previous prompt rewriting and optimization methods. However, it distinguishes itself by focusing on model-agnostic, fine-grained, and reinforcement learning-based prompt enhancement.
Yes, and the use of chain-of-thought reasoning is particularly innovative. It allows the rewriter to decompose complex prompts into manageable steps, ensuring that all relevant details are captured and clarified.
Before we wrap up, let's summarize the main contributions of the paper. First, PromptEnhancer introduces a universal prompt rewriting framework that significantly improves T2I model performance without modifying model weights.
Second, it develops a multifaceted reward model, the AlignEvaluator, trained on 24 key points across 6 categories, enabling fine-grained evaluation and effective alignment of the rewriter.
Third, it provides extensive empirical evidence of the method's effectiveness, including a new, high-quality benchmark based on human evaluation.
And finally, it demonstrates that prompt enhancement can be decoupled from image generation, offering a scalable and practical solution for improving T2I systems.
This is a major advancement for the field. It empowers users to express their creative intent more naturally, while ensuring that T2I models can interpret and execute those instructions with greater fidelity.
Absolutely. As T2I models continue to evolve, frameworks like PromptEnhancer will play a crucial role in making these technologies more accessible, reliable, and user-friendly.
Well, that brings us to the end of our review. To summarize, PromptEnhancer is a universal, model-agnostic prompt rewriting framework that uses chain-of-thought reasoning and fine-grained reward modeling to significantly improve the alignment between user prompts and generated images in T2I models. It's a scalable, plug-and-play solution that sets a new standard for prompt engineering.
Thank you for joining us on this deep dive into PromptEnhancer. We hope you found this discussion informative and inspiring. Stay tuned for our next episode, where we'll continue exploring the latest breakthroughs in AI and machine learning. Goodbye.
Goodbye, everyone.